Hello everyone. In this video, we will learn how to combine several linear inequalities. This means finding the region that satisfies more than one inequality at the same time. We will use this idea to solve two common exam-style questions. First, we will draw a region from given inequalities. Then we will write inequalities that define a shaded region on the graph. If you have not watched the previous video on how to graph linear inequalities, I recommend watching that first and then coming back to this video. This lesson is a little more advanced, so it is important that you already know how to graph one linear inequality. You also need to know how to draw straight line graphs and how to find the equation of a straight line from its graph. I will leave the links to those videos in the description. Let's start by looking at the main idea behind these questions. When we graph one linear inequality, we get one solution region. But in exam-style questions, we often have several inequalities. Each inequality gives us a different condition. So the final answer is the region where all those conditions are true at the same time. That common region is usually labeled R. In this video, we will shade the solution region, so the shaded part will be the region that satisfies all the inequalities. In some exam questions, we may be asked to shade the unwanted regions instead. In that case, the solution region is the part left unshaded. The mathematics is the same. The only difference is what the question asks us to shade. So we always need to read the instruction carefully. Let's look at the first example. We need to draw and label the region R that satisfies these three inequalities. Y is less than 2. Y is greater than or equal to x minus 3. And 2x plus y is greater than or equal to 4. We will work through the inequalities one at a time. For each inequality, we will draw the boundary line, decide whether it should be solid or dashed, and then shade the side that satisfies the inequality. Let's start with y is less than 2. First, we draw the boundary line. To do this, we replace the inequality sign with an equal sign. So the boundary line is y is equal to 2. This is a horizontal line through y is equal to 2. The original inequality is y is less than 2. There is no equal sign, so the boundary line is not included. This means we draw the line dashed. Now we need to decide which side satisfies the inequality. We can use a test point. A test point is any point that is not on the boundary line. Here we can use the point with coordinates 0, 0 because it makes the calculation easier and faster. Substitute y is equal to 0 into the inequality. We get 0 is less than 2. This is true, so the point 0, 0 satisfies the inequality. Therefore, we shade the side that contains this point. For y is less than 2, this means we shade below the line y is equal to 2. This shows the part of the graph that satisfies the first inequality. Now we move on to the second inequality. Y is greater than or equal to x minus 3. We start in the same way by drawing the boundary line. Replace the inequality sign with an equal sign. So the boundary line is y is equal to x minus 3. This equation is already in the form y is equal to mx plus c. So we can use the y-intercept and the gradient to draw the line. Here, c is negative 3. So the y-intercept is the point 0, negative 3. This is where the graph crosses the y-axis. We plot this point on the graph. The gradient is 1. We can write this as 1 over 1. So from the y-intercept, we move 1 unit up and 1 unit to the right and plot a second point. Then we draw the boundary line. The original inequality is greater than or equal to, so the boundary line is included. This means we draw the line solid. Now we need to decide which side satisfies the inequality. Again, we can use the point 0, 0 as a test point because it is not on the boundary line and it makes the calculation quicker and easier. Substitute x is equal to 0 and y is equal to 0 into y is greater than or equal to x minus 3. This gives 0 is greater than or equal to 0 minus 3. So 0 is greater than or equal to negative 3. This is true. So the point 0, 0 satisfies the inequality. Therefore, we shade the side that contains this point. Now we can see an overlap between the first and second shaded regions. This overlap is the part of the graph that satisfies both inequalities at the same time. Now look at the third inequality. 2x plus y is greater than or equal to 4. Again, we start by drawing the boundary line. Replace the inequality sign with an equal sign. So the boundary line is 2x plus y is equal to 4. This equation is in standard form. A quick way to draw this line is to use the x-intercept and the y-intercept. Let's start with the x-intercept. The x-intercept is where the line crosses the x-axis, so y is equal to 0. When y is equal to 0, the term with y disappears. So we get 2x is equal to 4. Divide both sides by 2. X is equal to 2. So the x-intercept is the point 2, 0. We plot this point on the graph. Now let's find the y-intercept. The y-intercept is where the line crosses the y-axis, so x is equal to 0. When x is equal to 0, the term with x disappears, so we get y is equal to 4. The y-intercept is the point 0, 4. We plot this point as well. We draw the boundary line through the 2 points. The original inequality is greater than or equal to, so we draw a solid line. Now we need to check which side satisfies the inequality. We can use the point 0, 0 as a test point. Substitute x is equal to 0 and y is equal to 0 into 2x plus y is greater than or equal to 4. This gives 0 plus 0 is greater than or equal to 4. So 0 is greater than or equal to 4. This is false. So the point 0, 0 does not satisfy the inequality. This means we shade the opposite side of the line. Now we can see the overlap of all 3 shaded regions. This overlap is the solution region because it satisfies all 3 inequalities at the same time. So we label this region R, and that is the final answer for example 1. Now let's look at the second type of exam-style question. This time the region R is already shown on the graph, and we need to write the inequalities that define it. To solve this type of question, we need to be able to find the equation of a straight line from its graph. So, if you are not sure how to do that, I recommend watching the video linked in the description before continuing with this example. As a general rule, we write one inequality for each side of the polygon that defines region R. Here, region R is a quadrilateral. This means it has 4 sides, so we need to write 4 inequalities. To find them, we will follow these steps. First, we write the equation of each boundary line. Then, for each boundary line, we write a possible inequality. Finally, we check whether the direction of the inequality is correct by using a test point inside region R. If the test point satisfies the inequality, we keep that direction. If it does not, we reverse the direction of the inequality. To make the working clear, let's label the boundary lines A, B, C, and D. We start with boundary line A. This is a vertical line. For a vertical line, the equation is written in the form x is equal to a number. Here, the line passes through x is equal to 1. So the equation of the boundary line is x is equal to 1. Now we need to turn this into an inequality. The line is solid, so the boundary is included. This means the inequality is either x is greater than or equal to 1, or x is less than or equal to 1. Region R is to the right of the line, so we guess x is greater than or equal to 1. Now we check this using a test point inside region R. Let's use the point 2, 2. We can use this same point to check all the inequalities in this example. Substitute x is equal to 2 into our inequality. We get 2 is greater than or equal to 1. This is true, so our direction is correct. The first inequality is x is greater than or equal to 1. Now let's move to boundary line B. This is a horizontal line. For a horizontal line, the equation is written in the form y is equal to a number. Here, the line passes through y is equal to 4. So the equation of the boundary line is y is equal to 4. The line is dashed, so the boundary is not included. This means the inequality is either y is less than 4 or y is greater than 4. Region R is below the line, so we guess y is less than 4. Now check this using the same test point. 2, 2. The y-coordinate is 2, so we get 2 is less than 4. This is true, so our direction is correct. The second inequality is y is less than 4. Now look at boundary line C. This is another horizontal line. It passes through y is equal to 1. So the equation of the boundary line is y is equal to 1. The line is solid, so the boundary line is included. Since region R is above the line, we guess y is greater than or equal to 1. Now we check this using the same test point. The y-coordinate is 2, so we get 2 is greater than or equal to 1. This is true, so our direction is correct. The third inequality is y is greater than or equal to 1. Now we need the last boundary line, D. This line is not horizontal or vertical, so we need to find its equation from the graph. From the graph, the y-intercept is the point 0, -2. The gradient is 1, so the equation of the boundary line is y is equal to x minus 2. Now we turn this equation into an inequality. The line is dashed, so the boundary line is not included. We first guess y is less than x minus 2. Now let's substitute the coordinates of the test point. Since x is 2 and y is 2, we get 2 is less than 2 minus 2. So 2 is less than 0. This is false. So our direction is not correct. We reverse the direction of the inequality. The fourth inequality is y is greater than x minus 2. Now we have all four inequalities. The region R is defined by x is greater than or equal to 1. Y is less than 4. Y is greater than or equal to 1. Y is greater than x minus 2. These four inequalities define the shaded region R. So we have written the inequalities that describe the region, and the exercise is complete. Now it is your turn. Write down the three inequalities that define region R. Pause the video here and try it yourself. Then press play when you are ready to check your answer. Let's check the answer. The region is a triangle, so each side gives us one inequality. For line A, the answer is x is less than 3. For line B, the answer is y is greater than -x. For line C, the answer is y is less than or equal to x plus 2. So the answer is x is less than 3, y is greater than -x, and y is less than or equal to x plus 2. I hope this video helped you understand exam-style questions on graphing linear inequalities. If you found it useful, please give it a thumbs up and consider subscribing. Thank you for watching, and I will see you in the next one.